All right, welcome back to the limits playlist in univariable calculus. All right, so one of the things that we want to do when we're evaluating limits is if we have a function like this, we want to see how the function behaves as x goes to infinity. All right, so what is infinity? Well, infinity isn't a number. All infinity tells you is the direction that a function is going. All right? So you can't really just plug in infinity necessarily in this equation, because let's suppose I just plug in infinity. Let's suppose I evaluate this function at x equals infinity. All right? So I'm going to have 3 times infinity plus 4, right? I'm just, anywhere I see x, I'm just plugging in infinity. I'm just going to kind of see what happens. So 3 times infinity plus 4 divided by 3 minus infinity. Because this is an x, I'm going to plug infinity in there. And I mean, if you really wanted to, just say it like this. This is not correct to write this. 3 times infinity plus 4, that's just infinity, right? And 3 minus infinity, that's, just negative infinity. But what does this mean? Well, it turns out it doesn't mean anything, all right? In fact, when I say this is infinity over negative infinity, it actually turns out this function actually, if you evaluate it at infinity, it actually is just a number. And in fact, it's a pretty small number, okay? It's a number that you can actually count on one hand. So the question I want to ask is, how do you determine how a function is behaving as x goes to infinity? Well, one of the things you can do, and there's different techniques we're going to look at, but when you have a function like this, there's one trick you can do that greatly simplifies it that will give you the answer. All right, so I want to ask you a question. All right, suppose I have a fraction. Let's just say just a number, a fraction. Let's say 3 over 5. Right? Let's say I have 3 over 5. In fact, let me actually change the fraction. Let me do one that's easier to conceptualize. Let me do the fraction 10 over 2. All right? Now, if I were to just take 10 over 2, 10 divided by 2, and plug it into a calculator, what do I get? Well, 10 divided by 2 is 5, right? Now let me ask you a question. Let's suppose I have this fraction 10 divided by 2, but let's say I'm going to multiply it by something that's referred to as a fancy 1. All right? What is a fancy 1? Well, if we just think about the number 1, right? 1 is just 1. That's just one finger, one toe, right? But what is 1 also equal to? Well, 1 is also equal to, say, 3 divided by 3, right? I guarantee you, if you plug this into a calculator, you'll get 1. It's also equal to 8 divided by 8, right? 1 is also equal to 1,000 divided by 1,000. So if I want to multiply by what's called a fancy 1, all I need to do is just multiply by something, a fraction, where the numerator is the same thing as the denominator. So let me ask you a question. Could 1 also be x over x? And the answer is yes, because whatever's in the numerator is also the denominator. If you take x divided by x, it's just 1. Now, one other form of this that's also very useful is 1 is also equal to, suppose I have this, 1 over x divided by 1 over x, right? So let's say instead of x over x, it's 1 over x divided by 1 over x. Is this still 1? And the answer is yes, because I have the same thing in the numerator that's in the denominator. So that's also 1. Now let me ask you a question. If I take this 10 over 2 and I multiply it by, let's do it just to be simple. Let's multiply it by one of these fancy ones. Let's do 3 over 3. We multiply this by 3 over 3. What do I get? What's 10 times 3? That is 30. And what's 2 times 3? That's 6. Now, run this into your calculator, and if you take 30 divided by 6, that's 5. That's also what we got when we just had 10 over 2. But if I multiply by 10 over 2 by a fancy 1, 3 over 3, I get the exact same answer. Okay, so the question is, if I have 10 over 2 and I multiply by 1, does it change? No, it's still 10 over 2 or 5. So the key thing here is with any function, as long as I multiply it by a fraction where the numerator is the same as the denominator, I don't change its value. So what I'm going to do is I'm going to ultimately evaluate this function as x goes to infinity, and I'm going to rearrange it such that it becomes much simpler to solve. So what's your typical limit nomenclature? You say the limit, and under this you have x, and you say where it's going to. Well, x is going towards infinity. That's also kind of a simple way of saying you could think of it like x equals infinity. Okay, but in limits we use an arrow to denote that it's going towards it. But this is like x equals infinity, and it's the limit of this function right here. So 3x plus 4 divided by 3 minus x. Okay, so I want to evaluate this at infinity. And we already showed that if you just plug in infinity, you get nonsense, right? So what can I do to ultimately get this into a form that's much easier to deal with? Well, what I can do is, suppose I do what I did here. I multiply by a fancy 1. But what I'm going to do is I'm going to multiply by the fancy 1 that is 1 over x divided by 1 over x. Okay? So, and I didn't change the value of this limit because this essentially right here, this is just 1, right? So now I want to distribute this 1 over x over both terms. All right, so this is going to be the limit as x goes to infinity. Remember, to get this correct, you have to keep writing the limit. All right, so what I'm going to do is I'm going to take this top 1 over x, and I'm going to first distribute it to this 3x. All right, so this is going to be 3x divided by x, because this is 1 over x, 3x divided by x. And then what I'm going to do is I'm going to now distribute this 1 over x to this 4, right? So it's going to be 4 times 1 over x, or 4 over x, right? Divided by, now, what I can do is take this denominator 1 over x and distribute this to the 3, right? So 3 times 1 over x is what? It's 3 over x, right? And then I'll take this 1 over x and distribute it to this minus x. So that becomes what? Minus, and then it is just x times 1 over x, or x over x. And now we can do a little bit of simplification. 3x over x. Notice that these x's cancel, right? X over x is 1. And here I have an x over x. That's just going to cancel to leave 1. So I can rewrite this limit a little bit. This limit is equal to the limit as x goes to infinity of 3 plus 4 over x divided by, this is 3 over x minus 1. All right, now at this point, we can actually just evaluate this limit, all right? So here's a question for you, all right? And I really challenge you to pause this after I explain what to do and just try this on your calculator, okay? So let's suppose you have the number, let's say you try to divide 1 divided by 10. I'm actually going to look at my calculator. Suppose I have 1 divided by 10. What do you get? You get 0.1, all right? Now take 1 and divide by 100. What do you get? 0.01. Now take 1 and divide by 1,000. What do you get? 0.001. Now take the 1 and just divide by, I don't know, like something like a trillion or something. What you can hopefully see is that when you take a number, just some number, and divide it by a huge, huge number, what is that value approaching? It's approaching 0. The number's getting smaller and smaller and smaller. So if I ever have something that looks like this, like 3 over x, or 4 over x, if I'm evaluating that at infinity, what is 4 over infinity? It's just 0, right? If I have any number divided by x, and I'm looking at x going to infinity, this is 0, right? I mean, take this for example. Take 4 in your calculator and just divide by, put a 1, and then just put a ton of zeros. Like, I don't know how many zeros I have that I'm typing, and I have a ton. And 4 divided by, I don't know what that is, and hit enter. And I'm getting like 4 times 10 to the minus 35th. But you can see, hopefully, as it approaches infinity, that number is going to be basically 0. So anytime I see like a 4 over x, or a 5 over x, 3 over x, 10 over x, doesn't matter what that number in the numerator is. If it's over x, and I'm taking x going to infinity, it's 0. So this term is 0 right here. And then this 3 over x is also 0. So what am I left with? Well, I can drop the limits now because all I'm left with are this 3 and this minus 1. So I have here, the answer is going to be 3 divided by negative 1 or negative 3. And so this is the limit of this function right here as you take x out to infinity. All right. So a lot of times, and I'm going to give you kind of some tips on this. We talked about very early on polynomials. If you have a function that is usually like a quotient of polynomials, so like 3x plus 4 divided by 3 minus x, something like that, and you want to evaluate it at infinity, an infinite limit, okay? The best method to do usually is this method, where you basically multiply the numerator and the denominator by 1 over x, okay? So hopefully that makes a little bit of sense. Now, I want to also show you another case where you do something almost identical to this, all right? So let's suppose now you have a function, and I also want to evaluate this as x goes to infinity. Suppose it is, let's say, 4x squared plus 3, and I want to divide that by, let's say, 3x squared plus, let's say, 8x. All right, so I want to evaluate this as x goes to infinity. So x is going to infinity. Well, if I just try to plug infinity in here, notice what happens. If I plug infinity in, I'm going to get 4 times infinity squared plus 3 divided by 3 times infinity squared plus 8 times infinity. And you could basically say you could say it's infinity over infinity, but this doesn't mean anything. It's nonsense. So that means we have to simplify this function a little bit to get it to where it's easier to solve. And again, you're going to see it's a pretty simple numerical answer, similar to what we actually got up here. Okay. So what I want to do is I want to take the limit as x goes to infinity. Again, it's sort of like saying you're plugging in infinity. And it's going to be of this function, 4x squared plus 3 divided by 3x squared plus 8. All right? Now remember what I can do here. I could multiply by a fancy 1, but I want to, and I'm going to do it down here, introduce you to another fancy one that's also applicable. Notice here that my exponent in this case on each x of the polynomial is actually a 2. Right? The highest one is a 2. So because the highest number here is a 2, my fancy 1 is not just going to be 1 over x divided by 1 over x as it was up here. I can actually do this as 1 over x squared divided by 1 over x squared. So my question is this 1 over x squared divided by 1 over x squared 1? The answer is yes. I have the same thing here in the numerator that I have in the denominator. So it's sort of like, it's the same thing as dividing 6 by 6. It's still 1, okay? So what I'm allowed to do is I'm allowed to multiply both the numerator and the denominator by 1 over x squared divided by. 1 over x squared. All right? So what is that going to do? Well, the first thing I'm going to do is I'm just going to write my limit here so I'm prepared for that. Limit as x goes to infinity. First thing I'm going to do is I'm going to take this 1 over x squared and I'm going to distribute it to this first term. So this is going to be 4x squared times 1 over x squared, which is 4x squared over x squared. And then what I'm going to do is I'm going to distribute this 1 over x squared to the 3 right here. So this is plus, because it's adding. It's going to be 3 times 1 over x squared, or 3 over x squared, right? And then for the denominator, let's see what happens. Then I'm going to take, let's see, this 1 over x squared and distribute it to the 3x squared. So what is that going to be? 3x squared times 1 over x squared. That's 3x squared over x squared. And then, let me do yellow. Take this 1 over x squared and distribute it to 8x. So that's going to be 8x times 1 over x squared, or 8x divided by x squared. All right, so what we can hopefully do now is we can simplify this limit. Okay, we can divide things through, so this is the limit as x goes to infinity. All right, so I have 4x squared over x squared. Well, x squared over x squared is just 1, so those cancel, and so that's going to give me a 4 right there. I'm going to have a 4 plus 3 over x squared. I can't simplify anything there, so I'm going to leave that as 3 over x squared. All right, can I simplify anything here? So I have this 3x squared over x squared. So this x squared over x squared is going to cancel to 1. So that's just going to leave a 3 right here. And then I'm going to add on to this thing. Now if I have, let's see, that was an 8. This is an 8 right here. 8x over x squared. Well, only one of the x's in the denominator will cancel with this x. So it's sort of like if I have x over x times x, then only one of these x's will cancel. So I'll still have something over x. So this will be 8 over x. 8 over x. All right? And now I want to see about evaluating this limit. Well, remember how we talked about up here on the previous example when I have something like 4 over x and I'm taking x out to infinity. We did that thing with the calculator where you just, you take a number and just divide by humongous numbers. And hopefully what you can see is that as x goes to infinity, the value of that goes to 0. So anywhere I have an 8 over x or a 3 over x, anything like that, this is just 0, right? Now, what about 3 over x squared? What happens as x goes to infinity there? Well, it's still 3 over x squared. It could be 3 over x squared, 3 over x cubed, 3 over x to the 4th, 3 over x to the 5th. It's still something over x, okay? So 3 over x squared, as x goes to infinity, this is still 0. Okay, so then all I'm left with is a 4 here and a 3 here. So this limit is actually equal to 4/3. Okay, and that's the limit there. One really quick thing to just keep in mind is remember that when you're doing this method of multiplying by the fancy 1, 1 over x divided by 1 over x or whatever, if you do the 1 over x, that's when the highest power here, notice, was 1. That's the highest power of x. Whenever you have the highest power of x being 2, as in this case, then it has to be 1 over x to the second divided by 1 over x to the second. Okay? If you had something that was like, maybe your function was, it was 3x to the third divided by 6x to the, let's say 6x to the third plus 5. Suppose that was your function, okay, and you had to evaluate that infinity. The way you would do that is the way you would get around this is you'd multiply not by 1 over x over 1 over x, not by 1 over x squared divided by 1 over x squared, but since the highest power here is 3, notice, then the highest power is 3, you multiply by 1 over x to the third divided by 1 over x to the third, okay? And that will ultimately get you the answer that you're looking for, okay? So hopefully this method of evaluating limits at infinity makes a little bit of sense. In another video, we're going to go over some other kind of important techniques that you can use when you're evaluating functions at infinity. All right. So hopefully this video helped. See you in the next video.